Last time we were trying an example on NC3. So we installed NC3 with Nextcloud with Docker Compose, and then we were trying to use a different version of database.
Hi everyone. We don't see the screen. Sorry for the interruption.
Okay.
Ciao.
Okay, thanks, Thomas. Because I reconnected and then I forgot to share the screen. I had the network connection. Okay, thanks.
You're welcome.
Okay. Last time we were trying to do an example. So we installed Nextcloud with Docker Compose, and by default it is using the database Postgres. The latest version is 18, I think, and we were trying to use another version of database, just as an example. And this is a good example in some cases when we want to migrate the application to another version. For example, either a newer version or an older version. This time we are trying to migrate to an older version, but it is not just as simple as using another image, because the data of the database which is stored here is already generated by the latest version of Postgres, which is Postgres 18. And if we try to use this data with Postgres 17, it fails somehow. It doesn't work properly. And so what do? First of all, we stop the application. And then we make a backup of before stopping the application. So let me start it again. We make a backup of the database, of the content of the database. So this is the files of the database, but we make a backup of the content of the database. And how did we do this? Let me check here. So we have this alias. So it is this alias here. And we are running the command psql nc3 user into the container of the database, and we are running it as user Postgres, and this is something related to interactivity. And now how we do the backup? I will do the backup again here. No, this is the restore. We use pgdump to backup the database. So it is this command here. So we run the command pgdump with this user, and the backup of the database. So this pgdump is an alias, is this alias here. It is replaced by the shell with this command. And we are also appending these options, clean and the database that is going to be dumped. And we are redirecting the output to the file nc3db.sql. So this contains SQL commands. This is an SQL script, and these commands are pretty much the same for all the versions of Postgres. So this will work also on Postgres 17 and not only on Postgres 18. So their syntax does not change so often. So we can restore this content to another version of database. Now, besides the content of the database, we also need to make a backup of the files of Nextcloud. And these files are on the directory data. So this directory contains the files of Nextcloud and the user files, the files that are being managed by the users. So we also need to make a backup of this directory. And now I can stop the application and maybe okay, let me try it again. The backup that I did previously, maybe it is not a good backup because the application was not working, I think, because we were using this version of Postgres. So let me make the application work again and then make a backup and then change the version. So let me check that the application is working now. We have broken the application. Okay. Anyway, the idea is that after we make the backup of the content, which is this directory and this file, we reinstall the application from scratch. So we remove this directory and remove this directory and install it from scratch. So docker compose down. And then remove this directory. And this one as well. and then change the version of the database image and start it again. And now, because this directory is missing, the scripts inside the Nextcloud image are going to initialize the database as well. To run the initialization scripts, and they are going to initialize the database. But because we removed the data, this is a brand new installation, so it does not contain the previous data. So let's try to. Yeah, it needs sometimes to initialize. This application is running with the other version of database, but it does not contain the previous data because it is installed fresh. It is a fresh installation. But because we already made a backup of the data in this file and in this directory, we can restore this data to this new application. So it is still running the installation wizard. I'm not sure whether this is a good backup because the website was broken at the time that we made this backup, but we'll try to restore it anyway. But this is the idea. After installing it afresh, we make a restore of the data from this database backup and from the backup of the files. So it is installed. And now we use this alias to restore the database, the content of the database. And we also restore the data, the files. So now this contains the old content. And then we start the containers again. And I'm not sure whether it is going to work now, because at the time that we made a backup of the database, the site was broken. So I missed this one. Okay, but these are the steps. So now we will start with another topic, which is Docker scripts. And Docker scripts is a Bash framework. So it is a framework of Bash scripts that helps to manage these applications installed with Docker or with Docker Compose. Let's install it first, and let us install the dependencies. So these packages are dependencies of this script. And now we'll get the code of Docker scripts from GitLab. gitlab.com. Docker scripts ds, and we are going to store this repository on opt in this directory. So it is cloned into this directory. And now to install it, we go to this directory and run make install. It is going to install a command that is named ds. So this is the main command of Docker scripts. So it says Docker scripts version 3.0. The directory of Docker scripts is it has created this directory .ds, and the content of this directory is this one. It contains a configuration file and some global settings. And the content of the configuration file, it defines some settings here. This is the repository where this is the base of repositories that contain different applications. This is the directory where the scripts are downloaded by default when we pull them from GitLab. And this is the directory where containers, the applications are created by default, and so on. With the option -H, it displays a help information about how to use the ds command. So ds and then a subcommand and some arguments, some other arguments, and it can also contain these optional things here. This is for debugging, and this is the place where the command is executed, the path or the directory where the command is executed. And these are optional, and by default the command is executed into the current directory, similar to Docker Compose. So when we run Docker Compose command, it is usually executed on the current directory. And then the subcommands are this one: pull init info, etc. And we can also see the man page, which is very similar to this help page. So it contains almost the same information. And now let us see how to use it. We will start by creating some simple scripts. I'm creating a test directory where we are going to work for the time being. And let me create a directory and now inside this directory I'm going to create these two files, a Docker file that contains only this line, and a file named settings.sh. that contains only this line. So it is a very basic example for the time being. This file, Docker file, defines the image that is going to be built for this application. But this framework, Docker script framework, makes a pre-processing. Before building the image with this file, it makes a pre-processing with make. So actually this is not a Docker file syntax. This is a make syntax, and it is including another file here from the framework. And the file that is being included by the framework, we can check this one. Or let me create another window. So this is the directory of Docker scripts, and here there are some Docker files, and we are including this one. So it starts from Debian Trixie and then installs systemd, installs some other packages, and so on. So this seems very simple, but actually it is not so simple. It is including this file that contains all that details information, and because this is a common situation, so it is used frequently on the applications. We have the framework has extracted it into this file, and it is just including it. Now, these scripts do not build a container. We have to initialize a container that is using these scripts. So we can use the command ds-init to initialize a directory for the container. ds-init we are telling this command ds-init to use the scripts on this directory, and it is going to initialize the container into this directory. So this is showing a location where the container directory will be created, and it is starting on the current directory with this subdirectory. So the container is initialized on this directory. So the initialization is creating this directory and also is making a copy of this file settings.sh inside this directory. And it is also modifying it, and it is including the it is replacing the path with the full path to the scripts, and it is also adding these two variables, image and container. This is the name of the image that will be built, and this is the name of the container that will be created based on this image. And by default, it is assigning the name of the script directory to the image. So this is the name of the directory where the scripts are located. And by default, it is assigning the name of the directory of the container of the application. So the directory is named app1, and this variable is also being assigned this value. I can modify this one, and also I can modify this one as well. These can be modified. But I should not. It is not a good idea to change this one, because this shows the framework where the scripts are located. So this one should not be modified. And now I can build this container with the command ds-make. This command ds-make is building the image for this container, and then it is creating the container itself, and then it is also making some configurations to this container. So it is doing these three things: build the image, create the container, and then customize the container or make some configurations into it. And we will see these steps later as well. It is still building the image right now. And now if we check, for example, docker ps, we also see this container running. So the name of the container is app1, but the name of the image is scripts1, and it was created 26 seconds ago, and it is up for 21 seconds. So this is what has been created by that command. And here on the list of images, we have lots of images, Docker images that we have created previously. But here we should also see, okay, it is this one here, scripts latest. So this is the image that was been, Docker image that was created for this container. And if I run the command dsinfo inside this directory, it should give me some information about this container. So it is listing the settings. The app directory is this one. This is the directory of the scripts. The name of the image is this one, and this is based on the information from these settings. So here is the name of the image is stored in this file. The name of the container is this one. Again, it is the variable in these settings. There are no ports shared. And then, so these are the settings. And then the name of the image is this one, created about a minute ago, size. The name of the container is app1, created about a minute ago, and so on. Now, if we look at the structure of this directory, we also see this directory logs and this file inside this directory. This is actually a copy of the output that was generated during by the command ds-make. So everything that we run with the command ds, for example, ds-make, the output is displayed on the screen, but it is also appended to this log file for later inspection, because we see that this command ds-make takes a long time. It may even take longer if it is a bigger application, and we can run this command ds-make, and then maybe we come later to check the result, and we can find the output from the command here into the log files in case we want to see whether there is any error during the process. So the output is stored on this log file as well. and we can get a shell inside the container that we just created with the command ds shell. So I am inside the container, and the host name of the container is app1. The working directory is this one, /host, which actually is mounted from the host. It is this directory from the host that is mounted inside the container into the path /host, because we see the directory logs and settings. So if I create something here, for example, touch test.txt, and I go out of the container, I see this file in this directory. So the directory of the application, this one, is also mounted inside the container itself. And this is convenient for exchanging files between the host and the container. Now the prompt inside the containers has this look. We can change the prompt with a command like this: ds inject This is like a script, a small script that changes the prompt, and the command ds inject is copying this script inside the container and then is executing it. So copy the script to the container and then execute it. And it also shows the path of the script that is being executed. So actually it is this directory on the system that contains the files of the framework. And it is copying this script from the script of the framework, of the Docker script framework. And it is changing the variable ps1 inside the container, because this script is being executed inside the container. So if we check, now we see that the prompt is a little bit different from the prompt that we saw before. So it has changed the prompt. Another command is ds stop, and it is going to stop the container. And if we want to start it again, ds start. And by the way, all these commands, ds shell, ds stop, ds start, does not specify the name of the container where this command is being executed. And it is because the name of the container is inside this file. So the framework is looking for the name of the container inside the settings.sh. It is using the variables inside this this file, and it knows where to run, which container to stop, which container to start. And this is why we have to execute these commands in this directory, because it is looking, it is using the variables inside this this file settings.sh in order to know what is the name of the container, what is the image of the container, etc. We can use the option minus D for debugging. And it is actually showing the Docker commands, because this DS is a shell script that is running something. And with this, and eventually it is running Docker commands. And with this option -D, it is displaying which Docker commands are being executed by this command. And for the command ds stop, it actually runs the command docker stop up1. Up1 is the name of the container. And the command ds start actually is executing the command docker start up1. We can also do a restart, ds restart. It is just running the command docker restart. And we can use the command exec to run a command inside the shell. So it is actually running the command ls-l inside the container. And the docker command that is being used for this is this one. Docker exec -it, name of the container, this environment, it is defining this environment variable, and then the command that is being executed. And also when we run ds shell, actually it is running this command, docker exec user options it, the name of the container, environment, and then run the command bash inside the container. Another debug option is -x, ds -x, and then some command. For example, make. The command make in this case is going to rebuild the container. So it is going to build again the image, then create the container, and then make some configurations on it. So if we look at the output, this -x is actually showing us what bash commands are being executed, because this is a bash script actually. It is a bash script, and it is displaying the steps or the commands inside the bash script. So this is used for debugging the framework itself. For example, if something is not working as expected, I can use this this option to trace the steps that are being executed by the framework, and to figure out why the result is not as expected. For example, just to debug the framework itself. So here, finally, we start with ds build, which is building the image. And actually, all of these are cached because we have built this image previously. So Docker it is using the cached version. And then ds create is creating the container from this image, and then finally it is running also ds config. We can also try to combine these two options, -x and -d, this -d is going to show the Docker commands that are being used by the framework. So these are bash commands, and then the command ds-build actually is using this Docker command, docker build tag. This is the name of the image, and then it is using a temporary file because it is pre-processing the Docker file. Before building the image, it is making a pre-process of the. This is the output from Docker build, and then the command ds-create is first stopping it, and then creating a new Docker container with this docker create command, and then start the new container. Then the command dsconfig is doing nothing actually right now. And if we redirect the output, we'll see only this output, the debugging output. So the debug output goes to standard error, and the normal output goes to standard output. We are redirecting the standard output, so we see only the output of the standard error, which is the debugging output from this -x. Now, if I run again ds shell, what we notice? We see that the prompt that we modified previously is undone. So the modification is not preserved. Why? Because we did a ds make, and this ds make is building a new container. So it is deleting the old container and it is building a new one. And so the modification that we did inside the container is not preserved. So how can we make that modification persistent? So when we run dsmake again, it should keep the modification of the prompt. How can we do this? We can do this by modifying this step, dsconfig. So we can customize this step, dsconfig, so that it can also modify the prompt inside the container. And how can we modify this configuration step? Let me create this directory, cmd. I'm going to create a custom command. And then I'm going to create this file config.sh inside this directory with this content. So, by convention, I'm creating this this function. This is the name of the command, dsconfig. The name of the function is cmd_config by convention, and it is stored on the file cmd/config.sh. So now if I run dsconfig, it is going to execute actually this script, not the default script of the framework. And because it is going to execute this configuration script, it is going to run the command dsinject change prompt.sh. So whenever I run dsmake, it is going to run also dsconfig here as the last step, and this command dsconfig is going to find this script command /config.sh, and it is going to execute this script instead of the default configuration script of the framework. And inside this script is this function. It is going to execute this function, and it will run this configuration command. So let me try again dsmake. And we see that the last step is execution of this configuration script, which is going to modify the prompt. So if I check now, the prompt is customized or is modified. So this is how I customize the configuration of this container. Now let me build another container with the same scripts. So I'm going to initialize it with ds init. I'm going to build a second container which is similar to this one because it is going to use the same scripts as this one. Ds init. The scripts are this is the directory of the scripts. So I'm telling the command ds init use the scripts in this directory and initialize the container into this directory. And it has initialized it into this directory /var/test/up2. So this is the directory of the scripts themselves. This is the directory of the first application, and now it has initialized another directory for the second application, which I have named up2. It contains only this file, scripts. Settings. And this settings contains the directory or the location of the scripts, and then the name of the image is scripts1. It is the same image as the image of the first application, but the name of the container is different. It is named up2. And now let me build the second container, dsmake. But if I run dsmake into this directory, it is going to build this container, the container up1. Actually, I want to run it into the directory of the other container, var test up to. So if I specify the directory after the command ds, then the ds command is going to be executed into this directory. So it is going to run the command make, but not in the current directory, in this directory. So it is going to build the second application. So the name of the image is the same, script1, but the name of the container is this one. Now, with ds shell, I get shell into the second application, and we see that the prompt is the default one. It is not the customized one. If I want to customize the prompt of this application as well, then I can do the same thing. I can customize the configuration step or the configuration command. Let me copy the same script from so I'm going to copy the directory cmd from the previous container. Into this directory. So I copied this config.sh cmd. It is the same modification. So I am defining customization for the configuration step into this file. And now if I rebuild the container, ds make rebuild the container, it is going to run the this step during the configuration, which is going to customize the prompt. So the prompt of the second container is also customized now. But we are repeating these steps. So the same script is being used for the first application and also for the same application. It is exactly the same script. Can we factorize it? Can we place it at the level of the script? So instead of creating it twice on app1 and app2, can we create it on the directory scripts one? So we can actually do this. So I can make a copy . So I created a copy of this directory with this config.sh inside into the scripts. And now I'm going to remove this from app1 and app2. And also remove it from app2. And now we have this directory cmd and this customization on our configuration script into the directory of the scripts, but we don't have it on the directory of the applications. Now let me rebuild these two containers and see whether this configuration script is going to be executed. So I'm running the command dsmake at this location, at the directory of this application. And now let me run it let me rebuild the other container. It seems that the customized configuration is working again, and let me check ds shell, the shell of the second application, the prompt on the second container is customized, and also let me check on the first application. It is customized on the second application as well. So how does it work? It works because the framework, the command ds make, when it tries the command ds config, because it is going to run eventually ds config to customize the configuration of the container, it is checking at several places for the cmd config.sh. It is looking at the directory of the container itself. It is looking at the directory of the scripts. It is also looking at the directory of the framework itself. So if it finds a copy on the directory of the container, it is overriding the copy on the directory of the scripts. If it does not find a copy on the container, it will use the copy on the scripts. If there is no copy on the scripts, it will use the default configuration script of the framework, which actually is empty. It does not do any custom configuration. So this is how it works. Now let us build a new ds command the same way. So here on the script we have this directory cmd, and we have this script config.sh. I want to build a command ds hello that is printing some information from the container. And to build this command ds hello, I'm going to create a file hello.sh into the directory cmd. So let me create this script. Nano and the content of the script is one function. I am defining this function cmd underscore hello. Hello is the name of the command. And I'm reading the first argument. The first argument is going to be a name. Check that it is not empty. So this is a test that this variable is not empty. Otherwise, if it is empty, it will fail with this message, which shows how to use. So it is going to show that this command is expecting an argument. This fail is a function defined by the framework. And it is printing this message. Hello, name. Name is the argument that is being passed to the command from container. This is a variable that is taken from settings.sh. So if we look at settings.sh, we see this variable container. So these variables are available inside that script and can be used. And in this case, we are using the variable container. So let me test this command, hello. First of all, we see that we have this hello script inside this cmd directory, inside the scripts directory. Now, if I go to the first application and I run ds hello, it is showing the usage because it expects an argument. So I'm passing a name as an argument, and it is displaying this message, hello Dashamir from container app1. This is the name of the container. Now, if I go to, or if I run it from the other container, ds so I am running the command ds hello, but on the directory of this container. And it is displaying this message from container up to. So the argument that I'm passing to the command ds hello is actually passed to the script, to this script, and to the function that is defined inside this script.